Good afternoon. My name is Danielle Smith, and I'm the Technical Sales Manager here at EDL. And today I've got Don Polsky, our head engineer, here to talk a little bit about our CryoCal. And I wanted him to be the one to do this video because oftentimes our customers need customizations and modifications. We can build whatever you need, and if that is the case, it's a good chance that you'll end up talking to Don about your specific requirements. So I'm going to turn it over to Don and let him talk a little bit about what our CryoCal consists of and actually let him do a temperature measurement. Don?
Basically, the CryoCal consists of a stainless steel container which has a high purity copper block internally with an internal RTD sensor. You'll see these stainless steel tubes here, which are called spacer tubes. Well, we call them spacer tubes. And this is your cabling running up into your socket. And what happens is when you use the CryoCal, it's a passive cooling system of liquid nitrogen, which you can see some of the liquid nitrogen vapor still coming out of this tank. And this is the reservoir that we're going to use to fill it when we put it in. When you get this system, it's going to be, this is your fill indicator, which is set up separately. These are the tubes which would come with it. They're in this block already. And these bushings, Teflon bushings, are designed just to reduce the amount of air that gets down into the chamber.
Standard well size is 8 millimeter. However, we are able to customize that. I also want to mention that we do offer guides and spacer tubes in additional sizes.
Basically, the first thing that you'd have to do is, when this comes in, is you would insert this through the tube, through the cover, and you'd put the Z-clip on. The reason we don't ship it with this on is because it's too easy for things to get damaged in shipment. Once that's in, this is now set up. This allows you to rotate it for easy viewing. And then when you go to insert this, we typically pre-fill the canisters about halfway, and that allows the dewar to pre-cool, and when you put this in, you're not taking a chance of it boiling out and causing a lot of problems. And as you can see, that's the cooling. As the block hits the liquid nitrogen, of course, it boils, and that causes the vapor display. Take this, drop this in there, then we can now take one of the important things when you work with liquid nitrogen is just take your time. Don't rush it. If a little spills, it's not going to damage anything. You just don't want it to stay resident on your skin for any length of time. Now, depending upon what temperature you're going to work at, that would determine how full you make your tank. Typically, we always recommend to fill the tank and start at your lowest temperature, and then as your level is decreasing, you then start increasing your temperatures. That way you're burning off less liquid nitrogen than if you started out and kind of run up and down a scale. As you can see, we're now about a third full of the tank. And what that means when you're a third full is that you're covering part of the block. We like to start out with it at the full mark, which brings your liquid nitrogen level above the top of these spacer tubes. And what that allows is for the liquid nitrogen to enter the block and cool it quickly and to maintain it at the true point of the liquid nitrogen, which is approximately minus 196 C. In the meantime, what we can do is we can plug this in. These are keyed systems, so there's a key. When you turn the power on, before you have your sensor plugged in, as you can see, there's this SBR which is showing sensor broken. That's because the plug is not in the system. When we put the plug in, it will occasionally self-correct, as this one did. If not, these left two buttons are pushed simultaneously and it'll reset the system internally. And as it is right now, we're at, as you can see, the temperature dropping. It drops fairly slowly by the self-cooling, and the reason for that is because the insulation in that stainless steel vessel, there's insulation to isolate the copper block from the liquid nitrogen environment. And that slows down, of course, the cooling. But it also adds tremendous stability to the system. And that's why we suggested in the beginning that you always start out at your lowest temperatures and work up, because the heating is directly attached to the copper block. So your heating is a much faster response than the cooling. And that's why it's easier to go up in temperature than down in temperature. Or I should say faster, not easier.
And that's also due to our exclusive, non-inductive, proprietary hand-wound
Right. Well,
heaters.
the non-inductive winding on the heating system is set up so that when you're using high precision SPRTs, you don't get any EMF feedback into the circuit, so you can get a very stable reading. And we can now take, these are set up for the 1/4-inch sensors, and
they are included with your initial purchase with additional sizes available.
so we've got a sensor in now. We're reading a temperature on the super thermometer, and what happens is you would now set your temperature to whatever temperature you want to apply by using these two small buttons on the right, which are the up and down buttons.
Or iTools. Or iTools.
Oh, well, iTools is the simplest way.
Which is
and-
included with your purchase as well.
Right. And once you've set your temperature, you would typically wait 20 minutes, half hour to get to your temperature going up. And then we always like to see at least a 15-minute to a half hour. Everything has to stabilize at the new temperature that you've established here. I would say roughly you're looking at 45 minutes to an hour to get, from one temperature to another. Now, if you're going down in temperature, it takes longer than if you're going up. At a temperature of minus 80, you can have a dwell time of hours. It just depends upon how full your tank is. We talk about 15-minute plateaus because the majority of labs out there all work in under 15 minutes on a reading. Technically, you can have a plateau using this system that would last many hours. We've often had temperatures of minus 100, minus 125,
12 hours.
which have lasted for 2-3 hours with very little drift. As your liquid nitrogen level changes dramatically, you will see a small drift in the plateau, which is expected, which is another point that I should mention, that if you are working for an extended period at, let's say, minus 100 C, and your next point is at minus 80, we would always recommend filling the tank while you're going down in temperature. And the reason for that is that if you stabilize at a minus 60 or minus 80 point, and then you want it to have an extended plateau. As your level is dropping, you reach a point where you have to put fluid in, liquid nitrogen, because your level is getting too low. When you do that, you'll see a change in your plateau. So if you've pre-filled before you reach your point, now you can extend your plateaus indefinitely, because it'll take quite a while. You could be looking at many hours before you have to refill the tank. So if you're at minus 100 and you're going to minus 50, while you're at that point, top off your tank, go up to 3/4 full or something, or full, well, not quite full, but up above the level that you're going to be needed at, so that when you get to your temperature, you won't be boiling it off too quickly, and you can have an extended plateau. As an example, I'm going to raise this temperature here above the temperature of the liquid nitrogen, of the copper block in the liquid nitrogen, so you can see vapors will increase as it starts to heat. We've made these CryoCals with larger dewars when necessary.
Smaller dewars when necessary.
Yeah, we can make them with larger blocks. The problem is, it's all a matter of what's needed and what's required. We don't like to over-invent something and make it more complicated than it needs to be. We have, in some cases, we've designed a CryoCal where you have a sensor for a jet engine or a rocket,
Aerospace,
where they have only an 1.5 inch long needle going into a temperature of minus 100 or minus 150 C, and it makes it a very tricky measurement because your length isn't long enough to really get a good immersion. So we've made special carriers which the sensor can
hanging
be
systems.
Right
We'll make
embedded
fixtures,
into
right, exactly,
to take your reading, and so we can change the lids, we can change the bushings, we can change the
Spacer
system.
tubes, yeah.
We can get the block much closer to the surface so the length can be reduced. Whereas, as you can see here, you've got a fairly long sensor, and 11 inches of that is what's going into this, because we want to get to the bottom of the copper block. We can make that much shorter. The problem is that as you go shorter, everything becomes more critical, and there's more heat path for the sensors to lose stability. So you don't want to make it too small, but as I said, if it's required, we will redesign it, and we can pretty much make whatever you need.
Including using alternative controllers. We
Right.
chose the Urotherm because this is a tried, true, and tested. It's never failed on us. However, if you do require a greater resolution, we are happy to customize and use your controller of choice, and we have done that quite a bit over the years. What I'm going to do is just talk to you a little bit about our CryoCal 2, which is the most trusted and affordable passively cooled cryostat available. It allows the user to calibrate a range of temperature measurement devices from 77K or negative 196 C up to 0 degrees Celsius. With our standard unit, you are able to easily and affordably calibrate up to 4 sensors at a time. The standard block is equipped with 4 8mm holes, with tubes and spacer guides included. They're designed to accommodate a 0.250-inch sensor. However, we do offer additional sizes. You may use the unit with or without the guides and tubes, with additional sizes available to accommodate any range of diameter sensors. Utilizing liquid nitrogen as the cooling media, we eliminated the need for expensive cascade compressor systems and cumbersome baths, making calibration at 113K or negative 160 degrees Celsius a breeze. You can also use liquid argon or carbon dioxide. Because of the proprietary custom-wound internal non-inductive heaters that we use, you can easily calibrate any temperature above 77K, all with dwell times greater than 15 minutes. Now, we're often asked about the length of time that the liquid nitrogen lasts. Don has spoken a little bit about that, but at negative 80 degrees C, with constant use, a full tank can last for about 14 hours. At the colder temperatures, dwell times are extended, possibly even to 2 days. But there are so many variables, and at the warmer temperatures, the higher the evaporation rate. So your liquid nitrogen may not last quite as long. Our standard units are equipped with an internal RTD for added accuracy. We utilize a high-precision Eurotherm controller with a resolution of 0.1 degrees Celsius with an RS-232 for communicating with your computer or PC, and iTools is included with your controller pre-programmed to ensure ease of use. Again, we can customize and use the controller of your choice, but this is our standard and our tried and true. We are able, again, to customize the CryoCal 2 and to use a more advanced controller if required. We're also able to make the door larger or smaller to fit your exact needs. In addition, we're happy to help with devising fixtures and holders, which have been especially helpful for aerospace, which Don just described. Please contact us for assistance. With no moving parts, pumps, or stirring systems, our CryoCal is virtually maintenance-free. And it's made in America by EDL, the temperature people since 1943. All of our units are thoroughly tested for stability and uniformity before shipping, and you will receive a NIST traceable calibration certificate with your purchase. Spacer inserts are available to accommodate your choice of sensor diameters of an 1/8 inch, 1/4 inch, or 0.276 inch, and we can always customize these as well. Standard 0.250 inch tubes and guides are included with your purchase, but again, we can customize as needed. It now features an easy-to-read liquid nitrogen level fill indicator to make your job of calibrating at these sub-zero temperatures easier than ever before. Trust EDL to take the doubt out of your measurements. That's what we're here for, the temperature people since 1943.